Alright, hey everybody, my name is Frank. This is the PothOnProgramming video log, and this is actually take 2 of this video because I didn't know what to do when I ran into a problem. I didn't want to just sit there recording for like 15 minutes while I figured it out, which is what it took. Anyway, today's video is supposed to be on fixed time step game loops, and that's what it's going to be on. But obviously with this format, I'm going to have to come up with some way to like pause and then restart. So what I'm literally going to do is just literally stop recording and start recording if I hit like a wall and I have to take like potentially an hour to figure something out. You guys don't want to watch me do that because it's not really interesting. Mostly it's just me like staring at the screen like this for long periods of time. So this is a learning process. Again, if you have comments for improvement or any suggestions for improvement, go ahead and leave them. That would be really helpful. Anyway, to the actual content of the video, we are going to try to implement a fixed time step game loop in the project today. By the way, this is part 3 of the Stay Down devlog. Man, gotta get these introductions figured out a little bit better. Anyway, so this is where we left off yesterday. This is all the code. I made a backup, so I just reloaded the backup files in. So this is all the original stuff where we left off in part 2. So basically what we're going to do is we're going to get rid of our plain old cycle function, our little game loop here, which is so simple and nice to look at. The reason this is no good, and someone actually left a comment pointing this out as well, is because depending on what device you're on, your game is going to run at different speeds, because your quest animation frame just gives you, basically it executes whenever your browser window is ready to redraw, and that is highly dependent on what device you're on. So for my phone, my crappy 2013 Google Moto G1, like the original Moto G, I think they're on like 8 now. This thing will run very slow, different from the computer, and if I was a little bit better at setting this video up, I would be playing the actual example on the phone and I would show you the difference in speed. But just trust me, there's a difference in speed, and that's what fixed time step game loops fix. So the first thing I need to do, and now we're actually going to start writing some real code, is I'm going to make a file called engine. Engine is what I'm going to call the object that takes care of the fixed time step loop. So I would normally make a class for this, but today, and for our purposes for this project, we're just going to call it, we're just going to make a single object, and it's not going to be a class because we're only ever going to need one, hopefully. So engine equals an object literal, and there's going to be one really weird thing that I'm going to show you guys about this particular way of doing it that is going to seem weird, but it's a way to get around having to bind this. And if you've ever had to work with binding this, it's nice to know there's a way around it because it kind of sucks. Alright, so the engine function is going to have a function, or the engine object is going to have a function called cycle, just like our old function. There we go. And it's going to have a function called start, and it's going to have a function called stop, because we're actually going to be able to pause the game. I figured I'd add the pause feature in there. This way we could actually show something besides just making a fixed time step game loop and you guys taking my word for the fact that it works. It's going to work, take my word for it, but also we're going to have a pause feature, which is going to be pretty cool too. So we have our 3 functions. Let's see, cycle is going to take, might be getting ahead of myself a little bit here with that. Also, we're going to need access to the update function and the render function. And let's do a setup function as well. Before, I'll put this all the way at the bottom. So for this to work, we're going to have to pass in the update and render functions that we defined in the main staydown.js file, and we're going to pass them in, and we're going to give engine its own pointers to those functions. So we're just going to say this.update equals update, and this.render equals render. And we're going to come into our main.js file. We're going to get rid of cycle. No longer do we have cycle. We're going to get rid of this window.requestAnimationFrame, and we're going to call engine.start. Doesn't do anything yet, especially because I'm pretty sure we haven't actually imported engine, like the script. So let's go ahead and pull the script in. Cool, cool, cool. Now it's going to do something, but it's probably not, well, it's not going to do anything, but it's actually doing something. Let's go back to engine and actually start this sucker up. So when we start, what I'm going to do is do window.requestAnimationFrame, this.cycle. Yes, for now we're going to use this.cycle. I'm going to try to show you the problem I ran into before and explain why it's a problem and why we want to do it differently. But I'm going to try to build this the wrong way first, or the way that I don't like first. It's not necessarily wrong, it still works. And then we're going to build it the way that I think is better. And hopefully you guys agree that it's better. If it's not better, please point it out and I'll look into it and try to fix it and make it actually better. So window.requestAnimationFrame, this.cycle when we call the start function, and we're going to say this.update, this.render. Update and render, and save. Let's see what happens. We got an error. This.update is not a function. What do you mean it's not a function? I have it right here. I'm calling, oh, wait a minute. I'm not calling setup yet. Getting ahead of myself. So before we start, we'll do engine.setup. It's still going to throw an error though. We're going to pass in update and render. Save, refresh. This.update is not a function. Okay, let's see what we get. Let's do a test, because so far don't really know what's going on. This console.log this.update. I just want to see if my setup function ran and my update pointer is actually pointing to the update function. So let's check this out and see. Okay, so this is clearly outputting the update function. So this.update is clearly something here in start, but inside of cycle, engine.js line 8 right here inside of the cycle function, this.update is apparently not a function. And the reason for that is because this is pointing to the window. Because when you use requestAnimationFrame, whatever function you pass into here is now going to be bound to the window object. So when you call this inside of that function, just kind of like an event handler, this is not going to be whatever object you define the function in, or whatever scope you define the function in. It's going to be the event listener, or in this case the window. Because when we request animation frame, essentially what I'm trying to say is anytime window.requestAnimationFrame calls a function, this inside of that function refers to the window and not the object that the function is defined in, like you might expect it to be. Okay, so let's actually test this and see what we get. So I'm going to get rid of this console.log. I'm going to go into the cycle function, and instead of using this, well, actually let's test it first. Console.log this. We're going to see what this is. I should have just did this instead of trying to explain it. So now when I console.log this inside of the cycle function, this is equal to the window, just like I was saying. So how do we get around this? So one way to get around this is the way that I don't like. But one way to get around this is to say engine.update and engine.render. And when I save, I'm pretty sure this is going to work. It works, but I didn't do one key thing, window.requestAnimationFrame, this.cycle, cycle, boom. Because this is no longer this, okay. Engine.cycle, okay. So now it works. But what I had to do was inside of my cycle function, I had to refer to engine with engine. So essentially, I'm looking up this object every time I reference engine inside of its own function. I don't want to do that. One way to get around this is to bind the this keyword to this function when you're doing your request animation frame call. I don't like that, and because we're going to be doing, from what I understand, bind is pretty slow, and because we're going to be using this on every single frame of our game, speed is kind of an issue. So I want to get good performance, and I'm pretty sure arrow functions get slightly better performance. So the way to get around this is with an arrow function. And the cool thing about arrow functions is they kind of like set up a state around themselves to where if I were to write an arrow function, it's going to, this keyword is going to be bound to whatever the context is at the time. So for example, I'm going to go into another project directory just to show you this real quick. I'm going to move my face real quick. I'm pretty sure it's in Rabbit Trap. Rabbit Trap. And I just looked at this a minute ago, so it's not like I'm just doing this from memory. Rabbit Trap. Maybe 7, 6. Here. Okay. So normally I'll make my engine a class that you can instantiate. So this is the arrow function I use to bind the this keyword. So right here what's happening is I have a class called engine. It has a property called handle run. And when I call handle run, essentially what it does is it calls this dot run. Now this is essentially the same as the cycle function that I'm making, but what's happening is the this keyword inside of the handle run arrow function is referring to the engine object that is created. So essentially I'm binding this engine object to the this keyword inside of this arrow function, and whenever this arrow function calls this dot run, this is going to be the engine object. So what I'm doing is inside the run function, instead of calling this dot run, I'm just calling this dot handle run. And when that happens, handle run kind of bypasses the window and it goes in, it says this, which is the engine, now calls run, and then everything inside my run function can use this the way you would normally expect to use it. I'm not the best at explanations. I hope that made sense. I'm going to show you how to do it now without using a class. It's kind of weird to look at, but we're gonna test it out. So what we're gonna do is we're gonna get rid of engine, the reference to engine inside of our cycle function. And the reason this is bad is because if I want to rename this to whatever, like my engine, or that spelling of ngn, what I would have to do is come into the cycle function and get rid of these engines. I'd have to change them all, which is stupid, and I don't want to do that. So engine, and inside here we're just gonna be optimistic and say this, and finally I'm going to attempt to make an arrow function to bind engine to the this keyword inside of my cycle function, so I can use this inside of my cycle function. All right, I think I got to do it like this. I'm going to make a function and I'm going to call it, how does this work? .call, the target is going to be engine. Essentially what I'm doing here is I'm making a class on the fly, and you can't really call it a class, but this is the way I do class inheritance. So for the sake of this explanation, I'm going to call this a class. I'm doing class inheritance from this anonymous function to the engine object, and the only property inside of this class or this anonymous function is going to be a function called this dot start cycle. I'm going to make that my arrow function. It's going to take a property or a parameter called timestamp, make my arrow, and then this dot cycle. Boom. And let me move this guy back over to the corner here. Okay. So what's happening here is I'm making an anonymous function, which you could see it as a class because technically that's how our classes are made. Like if I come over to player, this is just a function, but I can use the new operator to instantiate objects with this function. Those objects will have these properties. So basically what I'm doing is I'm making an anonymous class that has one property, and that one property is the this.startCycle function, which is going to be an anonymous function. And inside of this function's context, because I'm calling it on the engine object, this inside of the arrow function is going to refer to engine. And when I use this.startCycle inside of window.requestAnimationFrame, even though normally it would convert the this keyword inside of the function you pass it to point to the window, because arrow functions kind of maintain their state, this is always going to refer to the engine object. So I hope that's a good explanation. Let's just see if it works. I'm pretty sure this is going to work, but if not, we'll work out the bugs real quick. So this dot start cycle, start cycle. I think that's probably good. Save, refresh. All right, so it works. And let's see if we can actually get the timestamp in here. Cool. And that's another thing. So request animation frame, whatever function you want to call with request animation frame, the first parameter can be timestamp, because request animation frame is going to call that function and pass in a time, like a precision millisecond timestamp. It's going to pass that into whatever function you put in there as the first parameter. So let's see if I got all that right. Cool. So from the time you call request animation frame, this precise counter starts counting up. And so this is literally how far along we are in milliseconds since I used request animation frame initially. So that's pretty cool. So now that I know I've got all that working, I hope I didn't waste too much time trying to explain this whole thing. Maybe you guys get it, maybe you still don't get it. I wouldn't be surprised if my explanation is the only thing going on that you don't get it, but look into more of this stuff on your own and you should be able to figure it out. Basically, it's just a way to avoid having to bind this, which I think is probably kind of slow. All right, so now we can actually get into the fixed part of the fixed time step game loop. So, all right, let's see how we're gonna do this. Well, in order to have fixed time, we need a property to determine what that fixed time is going to be. So I'm going to call that time step. The time step is going to be, I don't know the exact number, but let's do 1,000 milliseconds is a second, right? Divided by 30 frames a second. So 1,000 divided by 30, whatever that is going to give us 30 frames per second. I don't need a semicolon. So I got my time step. Accumulated time, we're going to need that too. Put that up here. Accumulated time is basically going to just record how much time is left over after we do our updates. So in a fixed time step game loop, essentially what's going to happen is you start your game loop and time starts accumulating. Like you see down here, time is just building up and building up and building up. So as time builds up, you're going to look for a fixed chunk of time within that accumulated time, and you're going to update for every fixed chunk of time that's in the accumulated time. So let's say your game loop executes one time and it took 5 seconds to update. Let's say your fixed time step is 1 second. So when your device, which is apparently unbelievably slow because it's taking 5 seconds to do one cycle, when it gets to that 1 cycle mark, you will have recorded the time from start 0 to that 5 second mark, and your accumulated time is going to be 5 seconds. But your time step is going to be, let's say, 1 second. So what's going to happen is we want to update every 1 second for that accumulated time. So we're going to update 1, 2, 3, 4, 5 times to make sure our game is updating once every second. Even though our regular cycle takes 5 seconds, we want our game to run the same speed on all devices. So that means we need one update every 5 seconds. We might not be able to draw, or no, we need one update every 1 second, and if it's going to take 5 seconds, we need 5 updates. It's not going to redraw every second because the screen is only refreshing every 5 seconds, but we can at the very least make sure that we update every second, and that's the beauty of a fixed step loop, because no matter what device you play your game on, you might have to drop some frames, but you're going to be playing at the same speed, and that's going to do all kinds of good things like prevent people from taking advantage of like lag or something like that, and it's going to give a more consistent feel across devices for your game. So we're going to make a variable called accumulated time, and that's going to be equal to 0 initially. And we're also going to have a variable called, I think, current time. I don't know if I like current time. Also, I'm assigning these wrong. Should be a colon, not an equal sign. Okay, so let's see if we can do something with this. Inside of the cycle function, we're going to have to get the difference between the time that we're currently at when this cycle function is called and the previous time. So let's see here. Timestamp is going to be the most cutting edge time. Whenever this is called, timestamp is the most cutting edge time. I'm going to get rid of this so it doesn't overfill and bog us down. So let's see here. Current time equals timestamp. This dot okay, so let's say this function gets called once. The first time it gets called, current time is equal to 0. And elapsed time, and let's see, timestamp might be whatever it is. Timestamp might be a few milliseconds, if that. So the amount of elapsed time between 0 and whatever that is just going to be the timestamp value. So let's say the timestamp value comes in first time at 5 milliseconds. 5 milliseconds minus 0 milliseconds for the current time is just going to give us an elapsed time of 5 milliseconds. Then we need to record that in accumulated time. So this dot accumulated time equals, no, plus equals this dot elapsed time. Cool. So what we're doing is whatever that amount of time that has passed between frames is, we're just going to tack it on to accumulated time. So accumulated time at this point is just going to be increasing in value and increasing in value. So let's save and see if we got something that even runs. We do. Now let's do console.log this dot accumulated time, save. All right, so accumulated time is just going to keep on moving up and up and up because we're not taking chunks out of it yet. But now we're going to start taking out the time step amount of chunk out. So this is 30 frames per second. We're going to be taking out whatever number of milliseconds this happens to be. We're going to take it out of accumulated time. So while this dot accumulated time is greater than or equal to this dot time step. We got to be careful with while functions here because recording, don't want to make an infinite loop and crash this thing and then have to start over again. That would be the worst. So while this dot accumulated time is greater than or equal to the time step, so let's say our accumulated time is at 5 seconds again, our time step is the 1 second. While accumulated time is greater than or equal to, we're going to start subtracting the time step and updating the game. So if we have 5 seconds accumulated time and our time step is 1 second, we're going to do subtract 1 second, update, subtract 1 second, update, subtract 1 second, update until we no longer have any accumulated time left and we've updated as much as we can to get accumulated time down to 0. And sometimes we might have a little left over in accumulated time. That's okay. We're only going to be behind by maybe 1 frame. So at the most, we're only going to be behind in updates by a little bit of time that hasn't yet been enough past, like has not yet accumulated enough time to actually get past our time step amount. So let's go ahead and see if we can get this to work here. Now we're going to take the update function and put it inside of this while loop. And before I destroy my computer, I'm going to say this dot accumulated time minus equals this dot time step. Okay, so we're going to update and we're going to subtract time step from accumulated time. I'm going to save, I'm going to refresh. All right, cool. So now accumulated time is doing 2 things. Let's also, what is 1,000 divided by 30? I can't do stuff in my head because I'm trying to think and talk and write code at the same time, so I'm just going to have it do it for me. So 33 1/3, what is that, milliseconds? 33.33 milliseconds is going to be our time step. So when we look, our accumulated time is never going to be greater than 33. So at any given point in time, we're only going to be behind, and this is a worst case scenario because it's almost a full frame behind, but we're only going to be behind at most by a portion, never the full frame value, never the full time step value of 33. So this is our accumulated time. And as you can see, it's no longer accumulating infinitely because we're taking chunks out of it and updating. Now here's another cool thing that we got to do. Let's get rid of console.log. The other thing is we need to only draw when an update has occurred. So this is the cool thing about dropping frames. And actually, let's see. This should never even be the case. I don't know if this would ever even be the case where we have this set up and we don't have a reason to render. So let's say our computer is super fast, right? We don't want to update. We don't want to draw without updating. So this isn't normally going to be the case because normally the computer is going to be slower than your cycle rate, than your cycle speed or your time step. But imagine that you have a really, really fast computer, maybe you do, and this request animation frame gets called in less amount of time than your timestamp. So it gets called at, like, let's say 120 frames per second, and your time step is only set up to be 30 frames per second. So that sucker is going to call 4 times before you even want to update. I think 4 times, right? So what's going to happen is this cycle function is going to get called 3 times, and on the 4th time you're finally going to have enough accumulated time to justify 1 update. Now you don't want to draw on those first 3 frames because according to what you set up, you only want it to update every 30 frames per second, not at 120 frames per second. So you will have not updated a single time, but because your computer is so fast, it will have attempted to draw 3 times already before it actually has anything to draw, because you won't update until you hit that 4th call of the cycle function. So let's go ahead and fix that right now. And all we need to do to fix that is make a flag called updated. Updated equals false. So when you enter your cycle function, you're always going to have updated equal to false. And immediately, as soon as you make any update, you're just going to say this.update equals true. And you're only going to render nope. You're only going to render if updated is true. Interesting. All right, so now it's working. Cool. So check this out. And this is a good way to show that it's actually working. Okay, I'm going to get rid of that alert. I'm going to save. As you can see, I'm going a little bit slower than I normally would be going, because before I was just updating as fast as my computer could handle. But now I'm updating at the frame rate that I want to be updating at. So let's go ahead and go to 60 frames a second. It's probably going to be more in line with the speed I was updating at before. So this is 60 frames a second. This is what this looks like. Now you might notice it's a little more jittery. We can fix the jitter by using interpolation. So there's a technique called interpolation. I'm not going to get into it in this video, but we will probably have to use it to fix this jitter in the future. What's happening is I am taking whatever this is. I'm taking 60 frames per second. So once every second, 60 times every second, I'm calling the cycle function. The render is being called 60 times every second because I'm only able to update 60 times a second. If my browser window is not refreshing at 60 frames per second and it's only refreshing at 50 frames per second for whatever reason, I am going to still be recording the exact amount of time that has passed. So the computer's ability to update the screen doesn't inhibit its ability to keep track of the current time. So the current time is going to say, hey, you're only able to do 50 frames per second, but I know that 60 frames have passed in this most recent second. And I'm going to call my update function 60 times in that 1 second. Now, I might only draw 50 times. In fact, I would only draw 50 times because this function is only being called that many times. So some of these update functions are going to be called 2 times in a second because there's no way I can fit. In fact, let's illustrate this here. Let's do var count equals 0. Count plus plus. Count. Let's see what we get. So I'm going to get pretty consistently 1 because I'm choosing to run the game at 60 frames a second and also my computer runs at 60 frames a second. So right now things are pretty consistent. I'm getting 1 update. I'm never really, that's not varying at all. Let's see what happens when we start messing with this a little bit. So let's do 90 frames a second. See, there we got a 2. So there is actually a discrepancy between the 60 frames a second that request animation frame is trying to run at and the 60 frames a second that is actually passing in real time. But let's see what 90 frames a second looks like. As you can see, I'm updating at 90 frames a second because my guy is moving way faster. Let's bump this up to 120. Wow, that would be really stupidly fast. All right, so now I've got 120 frames a second. So this is the cool thing about the fixed time step loop. You can manipulate time as well in your game, which is pretty sweet. So at 120 frames, I'm updating 2 times per second because my frame rate is like 60 frames per second with this computer. So let's go back to 90 so we can get something that's in between. I just thought it'd be cool to show you guys how fast you can make stuff go. So here I'm right in between. My screen is refreshing at 60 frames a second, but my game is running at 90 frames a second. The update function is being called 90 times every second. So you can see that on every other frame, I update 2 times. Now I'm not rendering 2 times, I'm only updating 2 times. So let's prove that so we can actually take a look at it. How am I gonna do this? If updated, this dot render, it's always going to update and it's always going to render. I can't really prove this with console.log in this case, but we only render 1 time. So where it says 2 here, we have effectively called the update function twice in that frame, I guess you could say. In that screen refresh cycle, we have called update 2 times, but we have only drawn 1 time. If I was on a much slower device, let's see, if I was on a faster device, I might get 0. If I was on a super speed device, I might get 0. Instead of having a super speed device, let's make it a super slow frame rate. Let's do 10. Save. All right, so now every other frame I'm not updating at all. And the reason I'm not updating at all is because the accumulated time has not reached 100 milliseconds yet. 1000 divided by 10 is 100 milliseconds. So every increment of my game is going to happen 1 per every 100 milliseconds. And because my refresh rate is 1000 divided by 60, whatever that happens to be, 60 frames a second, that's faster than 100 milliseconds. I'm going to be not updating at all on some frames. 5 out of the 6 I'm not updating at all, and then on the 6th frame I'm updating. So this is it. This is a fixed time step game loop. Let me go ahead and clean this up a bit. There's one more thing I want to do. I want to make it so I can pause, but there's one more thing I want to show because there is a danger of overloading the system. I'm going to get into that in just a second. I feel like I had more to clean up. I do. Count. I don't need count. Don't need count. And save. And let's see what we get. Super slow. This is cool too because you can actually see how the Y velocity is increasing over time. At first you start out, you're falling really slow, but then you kind of pick up speed. So this is another cool way to test precision. Like if you're doing your collision, you can test how pixel perfect your collision is and stuff like that, and you can really take a look at what's happening. This fixed time step loops and the ability to change your frame rate, your update rate, is pretty handy when you're trying to like make something glitch out for testing purposes. Anyway, because we have a while loop here, and because we're going to try to run the update function as many times as it takes to catch up to the accumulated time, if our update function is really CPU intensive and it takes a lot of time to run, let's say our cycle, our time step is 100 milliseconds like it just was, or like it is actually. Let's say our time step is 100 milliseconds, but our updated function, or our update function, takes 200 milliseconds to run. We're going to have a serious problem because every time I try to update, and this is an insane scenario, 200 milliseconds to run. I don't know what you're doing in that function, but if that were the case, or even if it took 101 milliseconds to run, we're going to bog down the system, and this while loop is never going to execute because even though we're subtracting 100 milliseconds from accumulated time is going to keep increasing and increasing. So when we exit this while loop, we're going to jump back in the next time cycle is called, and the accumulated time is going to be 3 times as much, and then we're calling update 3 times more, and then it's going to be even bigger accumulated time, and then we're going to be calling update even more. So it's like you have the potential to brick someone's computer by bogging down their CPU in this while loop. So we need an escape. If someone's computer is ridiculously slow to the point where it can't run whatever your game code is doing, we get what I read online is a spiral of death. And I think I read that in some fixed time step tutorial like in 2012 or something like that, and it stuck with me. The spiral of death. Your computer just overloads the CPU and doesn't stop. So the way to fix this is to say if, really simple way to fix it, accumulated time is greater than, if accumulated time is greater than, you normally want to make it like 5 frames or something like that. So whatever your time step is, I don't want to come in and say this dot time step times 5. I don't want to do it that way, because why would I want to add another multiplication, another operation, what do they call it? I don't want to add another multiplication operation to my cycle, which calls every frame. This is probably a really small performance boost, but I would just use a number. I would say, what are we doing here? 60 milliseconds. If accumulated time is greater than 60 milliseconds, which if you're running at 60 frames a second, what is 60 frames a second? What is, I want to say it's like 16.7. 1000 divided by 60 is something that's not on the screen. 16.6. Okay, so if 60 frames a second is 60 chunks of 16.66, 60 milliseconds is going to be, what is that? 16 times 4 is 64. So it's going to be just a little bit under 4 frames. So if you're lagging behind by 4 frames, it's going to drop accumulated time. So let's just do, if accumulated time is greater than 60, this dot accumulated time equals 0. And this is going to make your game look stupid, because your accumulated time, you're just going to be, at this point the machine is too slow to run your game. So the user experience is garbage anyway at this point. There's no saving it. But what you can do is not brick their computer. So if this ever actually starts getting used, your game is not, it's too much for the computer or device it's on to handle. So this is a worst case scenario, but it just prevents accumulated time from getting super huge, and that prevents your while loop from calling the update function many times, trying to take out those chunks of time from your accumulated time. So this is just a way to save your users a little bit of pain while playing your game, even though their user experience is going to be bad either way. At least you know, brick their browser window or their computer. So, and I've actually had while loops overheat my CPU to the point where it broke. That was a bad day. It was a bad day. I lost a lot of stuff that day. Anyway, so that's something I want to show you, and then let's do a pause feature. Let's refresh that, see if it works. Did I break something? Apparently I broke something. Let's fix whatever I broke, and then we'll do the pause feature. The weird thing is, this dot accumulated time is greater than 60. The weird thing about this is I'm not even sure what just happened here. What did I change to break this? I'm sure that's not it. Oh, you know what? It is it, because my frame rate is so slow that any accumulated time is going to be over 60. So that's the perfect example. If it actually works. So if accumulated time, in our case, 10 frames a second is 100 milliseconds, you don't ever want your user's experience to be running at 10 frames a second. Maybe you do, but I certainly don't. So if you don't want the accumulated time, if you don't want the user experience to run at 10 frames a second, 60 is going to be just fine. Let's 60 is fine. I'm gonna increase the speed here to a regular amount. You can play with that, whatever is optimal for your situation is best, obviously. That's still a little too slow for me. I'm gonna go back up to 60. 60, refresh. And now I'm gonna make it so when I hit the P button, or the P key, I can go ahead and pause the game. So let's go over here. Let's find out what the P key is. Console.log event.keycode. Refresh. The P key is 80. Cool. So let's get rid of that. State and save, and then we're going to come into our update function. We're going to say if controller.p and engine dot I'm not going to do this. If controller.p, so we're hitting the key P, or the P key, if engine dot running engine dot stop, else. This is going to introduce another interesting situation because the timestamp is going to keep moving upwards, I think. So we're going to have to reset accumulated time when we pause. Otherwise, when we come back on from a pause when we start up again, we are going to have a ton of accumulated time. And actually, we're safe from that too because of what we just did. This is going to keep us safe from accumulated time building up like a massive amount when we're paused. So I guess we're good, but I still don't want to skip. I don't want that to happen. I don't want to reset it to 0. And actually, you know what I'll do? Instead of setting this to 0, a much better thing to do would be to set it to this dot time step. This way, even if accumulated time is super big, we're not just not updating at all. We're actually going to update one time. So that's slightly better. That's a bit of an improvement. Now let's go ahead and make this so we can actually pause it. I'm going to go ahead and make a function or a property called running, which I'm going to set to false initially. Then I'm going to do a property called RAF request animation frame handle. I'm going to set that to undefined. Cool. Now, whenever we call request animation frame, I'm going to set the RAF handle equal to the return value of that. So right here, I'm going to do this dot RAF handle equals window dot request animation frame. And down here, when I initially start things up, I'm going to do this dot RAF handle equals window dot request animation frame. When I stop, I'm going to do window dot cancel animation frame, and then the handle, so this dot RAF handle. Pretty sure that's all I need. Let's save it. Pretty sure it's not going to work at all. Doesn't work, but I'm pretty sure I also didn't do this quite right. So let's take a look at what's going on here. If controller.p console.log p, save, refresh, p is down. P is down. Engine not running is false. That's where I messed up. So let's go back. When I start, I'm going to do this dot running equals true. And then when I stop, I'm going to say this dot running equals false. And that should actually fix it. Of course, we're going to flip-flop between two states really fast. Ooh, that's terrible. What the heck even happened there? Anytime I press any key, and the reason is, let's see, if I come back up here, I left the break statement out. So break, save. So what was happening was when I was pressing the up button, or the right button rather, to go right, I was not breaking, and it was immediately running into the next case, which was for the P key, and setting controller P to whatever the state was, which is probably up or down, whichever. So let's go ahead and refresh. That should fix it. All right, so I'm moving around, nice, and I pause. So the pause works. Interesting. pause works, but I can't unpause for some reason. When I press P, nothing happens. Oh, wait a minute. That's because the update function shouldn't even be rendering anymore. Yeah, the update function is totally cut off. So I'm listening for the key press to P to actually set P controller.p to true inside of my update function. But once I stop the game loop from running, I can't actually detect if P's been pressed or not because update never gets called again. So that's really stupid. Let's go ahead and move this out and bring it into our controller function. Where are we here?
Honey, I'm home.
Hey. No edits. All right. Get out of here. Yeah, I know. All right. Instead of doing this in the switch statement, I'm going to come down to the bottom and I'm going to paste that right there for now, and we're going to see what we get. It should work now. So if I jump, I'm moving around, I'm going to press P, it's going to pause, I'm going to press P again, it's going to unpause. Alright, so that works pretty good. It's not perfect. I'm pressing P and it's not always working the way I want it to. Ideally, you wouldn't have this inside of your key down up listener. Although I guess you could. If controller.p, instead of even doing controller.p, we'll get rid of controller.p, especially because we didn't actually define it on our controller object, which I don't like just setting things when it's not defined on the object originally. So like inside a controller, what I'm talking about is in here, we don't have a value for P or a property for P. So let's get rid of controller.p and bring this whole thing into the case. And instead of setting controller.p, we're gonna say if state, then do this. So basically state is true when the key is down. So if the P key, key 80, is down and the engine is running, stop the engine. Else, if the P key is down and it's, this might not work either. If the P key is down and the engine is not running, we're gonna start the engine. The problem with this is when I hold the P key down, this event listener is going to continuously fire over and over again. So I think I am actually going to have to put a property for P onto the controller object, and we're going to have to do it that way, because check this out. If I just hold P down, you see how it's kind of, I'm holding P down, jumping, holding it, and it comes out again. And that's because, let's check this out right here. That's because the event listener is detecting that key down over and over again, but it's not a good way to do this, so I'm going to have to make a modification here. So you can see initially there's one high, and then after a brief time it adds on. That's the event listener starting to pick up that key down again and again and again, and it just happens really fast after that. So let's fix this, and then I'm going to close out the video. I'm going to go to the controller object. I'm going to make a value or property called P and make it false. Save. I'm going to come back in here, if state. I'm going to undo this here. I'm going to come in, I'm going to say X. I'm going to say controller.p equals state. And then outside of the switch, I'm going to say if controller.p controller.p equals false. And what this is going to do is every time state for p, oh wait, this might not work either. No, it's going to work because state won't change until I pull up on the key. So this is actually going to work. What this is doing is it's saying if controller.p is down, then set controller.p to up, false. And since the event listener is going to pick up that the key is down over and over again, like it was doing here, and it's going to detect that, we're going to set it to false manually inside of our condition here, and it's just going to work. So let's go ahead and test it out and get this thing going here. So save, refresh, P. Dang it, still is not working. Why isn't this working? So long as the P key is down. Oh, because I'm setting it back to true. I can make it not P. See what we get there. So this is not ideal, this is not really what I wanted, but when I have to actually release the P key in order to make this work. I don't really care for that very much. I'm gonna have to think about a way to fix this, and then I'll fix it in a future video, but for now, at the very least, which this is probably an hour-long video at this point, I don't know where I just looked to look at the time, but there's no time down there. I don't have a counter going or anything. You can see what I see on my screen. So anyway, I've already spent more than enough time doing the fixed time step loop, and we can tell that it works because we can adjust the speed of the game, and we got the pause function in there, which is pretty cool. So stay tuned for the next video. I'm not really sure what I'm going to do with it. Maybe I'll start making the platforms on the bottom and have those rise up. Maybe I'll go ahead and figure out a better way to do this pausing feature right here. Doing stuff on the fly, sometimes you get mixed up. Can't really take the time to just think about the design when you're just rolling stuff out. Otherwise, you guys would get a big dead air space going on in the video. But anyway, hope you guys enjoyed the video. Hope you learned something. Leave some comments, like the video, and I'll see you next time. Now I just gotta go in here and stop recording. Peace.